Hey everybody, it's Mr. P again, and we're going to look at section 10.4, and I'm going to call this part 1 because we'll do another segment on this in a future e-learning. In this section, part of the section will be on solving equations that have radicals, particularly square roots. So we've done some work with square roots so far, simplifying them, multiplying them, dividing them. Now we're going to look at solving equations where the goal is still to get the variable by itself, okay? That's still the goal, even when we have square roots in the equation. So we're going to outline a few basic steps for solving square root equations, okay? Solving equations with square roots. And then we'll go through some examples together. So the first thing you want to do is isolate or get the radical terms by themselves. That's what isolate means. So isolate the radical term. Okay, so where we see any term that's got a square root in it, we want to make sure we isolate that by itself on one side, or if we happen to have radicals on both sides, sometimes we'll have that, but that'll be our first step. If we have radicals that we need to get by themselves. So if there's other terms other than the radical terms, the square root terms, we need to like maybe add or subtract or multiply or divide. We'll see some of that. Step 2 would be to, once that's the case, you want to square both sides of the equation, which that's going to get rid of the square root. So squaring a square root gets rid of the square root. And then of course we would take the necessary steps to solve whatever equation's left. Alright, so again, isolate the radical or the square root term, square both sides of the equation. Okay, again, squaring is going to get rid of the square roots, and then take whatever steps necessary to solve. Alright, so let's go ahead and look at a few examples. So first of all, let's say I have square root of x plus 5 equals 10. Okay, so we said get the square root term by itself. I have plus 5. How do I get rid of plus 5? Minus 5, right? So minus 5 minus 5. I get square root of x on this side equals 5. Okay, so square root terms by itself. How do I undo the square root? I square both sides. So squared, right side squared, again square root, or squaring the square root is going to get rid of that. So I'm just going to have x equals 5 squared is 25. Alright, and we're going to see something, a term come up here called extraneous solutions. So those are solutions that don't work in the original equation. So what we're always going to want to do in this part and the next part of our of section 10.4 is test the solutions to make sure they work in the original equation. So my check on this would look like this. I'll take 25, plug it in for x, and verify that the equation's true. What's square root of 25 is 5 plus 5. Okay, does that equal 10? Yes. Okay, so that works. Again, that term, extraneous solutions, in case you see that. Extraneous means it wouldn't work in the original equation, but this answer does. So our answer is x equals 25. And any extraneous solutions we would not include in our final answer. Okay, we'll talk more about that in part 2 of this section. All right, let's take another one. Let's say I got 3 times the square root of x equals 6. Okay, so 3 times the square root of x, what is the opposite of multiplication? How do I get rid of multiplication? You should be telling me divide, right? Using division. Divide both sides by 3. So square root of x equals 6 over 3, which is 2. How do I get rid of square root? Square it, right? Square both sides. The square root's now by itself. So now I have x equals 4. Again, I'm going to check and verify that this actually works. So I'm going to plug in to my original equation, which was 3 square root of x, so I'm going to check. I'm going to plug in 4 for x. We're going to say, is this equal to 6? So square root of 4 is 2. 3 times 2 is 6. 6 equals 6, so that verifies that the equation is true when I plug in 4 for my x values. My answer would be x equals 4. Okay? Let's look at another set of examples. Alright, so let's say I have negative 2 times square root of x over 2 in the square root, and then I have equals negative 10. So let's first of all take a look. I have negative 2 times the square root. Again, what's going to be the operation that undoes multiplication is division. So divide both sides by negative 2. Those go away, so I have square root of x over 2. Negative 10 divided by negative 2, of course we know negative divided by negative is positive, so positive 5. Getting rid of the square root, I want to square both sides now. So when I square both sides, again, square root's going to go away. I'll just have x over 2 equals 25, which is 5 squared. And I can go ahead and put 25 over 1 and create sort of like a proportion here, basically is what we're doing. Cross multiply, right? X times 1 is x. 2 times 25 is 50. Okay, again, we have to check our answer, so let's do a check. So negative 2 times, and then it's going to be 50 over 2, substituting the x equals 50 back in. So we want to see if that's equal to negative 10. Negative 2, so 50 over 2 is 25. So times square root of 25, is that equal to negative 10? This would be negative 2 times 5, which we know is equal to negative 10. So both sides of the equation are equal, which verifies that x equals 50 is our correct solution. All right, let's look at one that's a little bit different. So on this next one here, I have square roots on both sides of the equation. So square root of x on one side, square root of 16 minus 3x on the other side. And so with this type of problem, okay, the square root terms are already by themselves on each side. So we go to our second step, which is to square both sides, which gets rid of our the square roots, so rid of the radicals. So that's the first thing we're going to do on these. Square both sides. Okay, remember that cancels out the square root. So literally, I have x equals 16 minus 3x. Okay, then we solve it like any other linear equation, getting x by itself, so I want to go ahead and add 3x to the left side here. So I have 16 and then 4x on the left side. Okay, so 4 times x equals 16. How do I solve that? Divide by 4, correct? So x equals 4, presumably, right? We have to check it. Okay, we got to verify it. That's, part of what you want to do, especially when we get into the next section where we have potentially 2 answers, but one may or may not, there may be one that doesn't work. So we want to get in the practice of plugging back in and verifying. All right, so square root of 4, is that equal to square root of 16 minus 3 times 4? Let's verify that. So we know square root of 4 is 2, so let's deal with this side here. 16 minus 3 times 4, so that's 16 minus 12, which would just be, would just end up being 4. So square root of 4, 2, and we know square root of 4 is in fact 2, so I get 2 equals 2, and there you have verification that x equals 4 is your solution. Okay, we'll have a couple more. So the next problem we're going to look at, let's say I have negative 7 on one side equals square root of 4x. Okay, 4x is all inside the square root, minus 11. Okay, so is a square root by itself? No. What do I need to do to get the square root by itself? Since I have minus 11, getting that to the other side would require me to add 11. So plus 11, plus 11. All right, so I'd have square root of 4x here. 11, negative 7 plus 11, that's going to be 4. And I need to get rid of the square root. How do I do that? Square both sides. Square, square. Remember, square root gets canceled by squaring it. So I got 4x equals 4 squared 16. Divide by 4. And x is 4. Again, we're going to just show the check here. So negative 7 equals 4 square root of 4. We're going to plug in 4 here for the x. Minus 11. So is negative 7 equal to square root of 16 minus 11? So is negative 7 equal to 4 minus 11? And the answer is yes. Okay. So negative 7 equals negative 7. And that verifies that 4 is the correct answer for x. All right. So the last one we're going to look at in this section is another one that's going to have variables on or square roots on both sides, and actually variables on both sides. So we've done work before just solving regular equations with variables on both sides, and that's pretty much what we'll be doing once we get rid of the square roots. So I will have square root of 2x minus 15 on the left equals square root of 3x minus 25 on the right side. Again, just like the other one that had the square roots on both sides, they're already by themselves, so I want to go ahead and square both sides to get rid of them. So squared, squared, again, square roots, they go bye-bye, right? So I got 2x minus 15 equals 3x minus 25. Again, a linear equation, something we should be familiar with solving. A few options here. I'll choose to go ahead and just subtract 2x from both sides to start off. So negative 15 equals x minus 25. So how do I get rid of a negative 25 here, or minus 25? I add it. So plus 25, plus 25. I get x equals 10. We need to go ahead and check and verify that that is the correct, solution for the equation. So I'm going to plug in 10 wherever I see x in the original equation. So 2 times 10 minus 15. Is that equal to square root of 3 times 10 minus 25? Okay, so 2 times 10 is 20. So 20 minus 15, and that square root, is that equal to, this would be 3 times 10 or 30 minus 25. What's 20 minus 15? That's 5, right? So square root of 5. Other side, 30 minus 25, also 5. So again, that verifies that 10 is the correct solution. Okay, again, in the second part of this section, okay, which you'll be doing for one of your e-learnings next week, we will look at more equations with square roots in them, and some where we'll actually have to be factoring and solving, which will give us a possibility of having more than one solution. But remember, not all the solutions always work. So that's why what we've done today is practice checking and plugging in. Okay, so see you guys next week.